Hello everyone, this is Streamer and welcome to Genius Math Minds. In this video, we are going to prove by mathematical induction. So what the proof is, prove that 2n plus 7 is less than n plus 3 the whole square for all n belongs to whole numbers. So this is whole numbers. So here the n belongs to whole numbers and this expression is actually an inequality or a less than symbol. So we have to do some other things that we did for when we are dealing with equal sign. So this will be kind of different compared to that. So first, n starts from 0, 1, 2 and so on. So the first value for n is 0. So the step 1 will be put n equal to 0 because the number starts with 0. So if you put n equal to 0 here, we get 2 times 0 plus 7. So this will be 7. And here it will be 0 plus 3 the whole square, which would be 9. So 7 is less than 9. So the expression is true for n equal to 0. We can also prove for n equal to 1. Just to be safe, we will prove for n equal to 1 as well. So put 2 times 1 plus 7. So this gives 2 plus 7 is 9. Then put n equal to 1 in here. So we get 1 plus 3 the whole square, which is 4 square, which is 16. So 9 is less than 16. Therefore this expression is also true when n equal to 1. So that is the first step. So we have proved that step 1, that is n equal to some variables or some constants we are proving. So now the next step is, so for step 2 we need to assume n equal to k is true. So when we put n equal to k here, the expression is true. So that's what we are assuming. So 2k plus 7 is less than n or not n, k plus 3 the whole square. So this is an expression that is already we are assuming. So leave it as that. So now step 3, put n equal to k plus 1. So if we prove n equal to k plus 1 is true, then this whole proof is solved. So put n equal to k plus 1. 2 times of k plus 1 plus 7. This is the LHS. So left hand side sum. From right hand side we have k plus 1 plus 3 the whole square. So this is the right hand side. So now if we prove 2 of k plus 1 plus 7 is less than k plus 1 plus 3 the whole square, then the proof is over. So we'll take this first. So let's say the LHS is 2k plus 2 plus 7. So distributing this 2 inside. So we have 2k plus 2 plus 7. So this is the LHS. So we can take from this 2k plus 7 less than k plus 3 the whole square. How we can do that is, we know the first expression is 2k plus 7 less than k plus 3 the whole square. So this is the expression we have here. So if we add 2 on both sides, so 2k plus 7 plus 2 less than k plus 3 the whole square plus 2. So this expression becomes this just by adding 2 to both sides. The inequality stays the same because we are doing addition in both sides. So if we see this expression and this expression, these are the same. So we can say 2k plus 2 plus 7 is less than k plus 3 the whole square plus 2. So that is gonna be one of these steps. So this is less than k plus 3 the whole square plus 2. So this is one proof, or this is one thing we have found out. Now what we need to do is, we need to prove this expression is less than k plus 1 plus 3 the whole square, because this expression is less than this expression. If we add 2 on both sides, that leaves them as the same. So 2k plus 7 plus 2 less than k plus 3 the whole square plus 2. What the final proof is, we need to prove this is less than k plus 1 plus 3 the whole square. So we have this here and this is less than this. So we need to prove this expression is less than this expression. So the final proof will be over. So how do we do that is, let's take this expression. K plus 3 the whole square plus 2. So distribute this. So k square plus 6k plus 9 plus 11. So 9 plus 2. So this is the expression we have here. So this is this expression. So now this expression will take k plus 1 plus 3 we can write as plus 4 the whole square. So this expression will be k square plus 8k plus 16. Clearly this and this are equal, and we have 6k here and we have 8k here. This equals 11 and this is 16. So clearly k plus 4 the whole square is greater than k plus 3 the whole square plus 2. So the final inequality will be 2 of k plus 1 plus 7. This is one expression. We found out that this expression is less than k plus 3 the whole square plus 2. We have found that. How do we found this? We found this by adding plus 2 to this expression from the assuming step. So now we also found that this expression is less than k plus 4 the whole square, just by distributing or using the a plus b the whole square formula. So this expression is less than k plus 4 the whole square. What do we have to prove here? We need to prove this expression 2 of k plus 1 plus 7, which is this one, is less than k plus 4 the whole square. So we have proved this expression is less than k plus 4 the whole square. So that's all about this proof. So what we are doing is, we have inequality here. That's why it is bit different to solve this problem or to prove this problem. So we are using the assuming step, adding 2 to both sides, so we get a new expression from this. Then we are using this and the RHS of this, and we are dealing inequality to that. So finally we will have 2k plus 1 plus 7 is less than k plus 4 the whole square. So that is about this problem, and that's why this problem is kind of different to other problems. So that's it. Thank you.